Course introduction, okay, LOC, okay, line of code. The software also they measure by line of code, okay, how much line of code that you have to it required for written one software, okay, one software. Okay, this one is example of 4 line of code, okay, for example, 4 physical line of code, okay, for example, this one you see 4 is 1, open bracket 1, print F is 1, and close is 1. So this one we call 4 line of code in general. Okay. If we look at the example of code base, okay, code base. This is measured by million, okay. You look at the first line is line of code mean every single line of code. Okay, there we go. One line is one code like this we call one line. Okay, this is another line, or this is we call 4 line of code. Okay. If you want to create some kind of application, okay, any kind of application or whatever, or any system, okay, any operating system or whatever, measured by million, okay, you know million, right? Everyone know million, okay. This is million line of code, okay, million line of code. If you want to create F2 Raptor fighter jet, okay, F2 fighter jet, it took almost 1.7 million line of code. Okay, it take 1.7 million line of code. If you want to Android, for example, this is operating system Android. If you are using Android on your smartphone, it took 12 million line of code. Okay, imagine that how long that million line of code. Okay, Facebook are using right now. It takes 62 million line of code. Okay. Modern car software as auto drive as Tesla auto car, it took 100 million line of code to write. Okay, to write the code. Okay, to write the code. It's very long, right? It's very long, right? Okay. If we are using Google search, Google Doc, Google Meet, we are using right now, Google Classroom, all the service that running by Google, it took 2,000 million line of code. Okay, 2,000 million line of code. My question is, how many million? Okay, we don't ask about million, right? Okay, we ask about how many line of code have you ever written. You can click on the link below, and then you will see the what we call infographic that explain about the code that it took for running some kind of application, okay, any kind of software, any kind of system software, okay, to run the code, okay. Take a lot, right? Okay, take a lot, right? It's not created just only in one day or one night stand. No, it take a year, 10 years, 20 years to run that, okay. Or you may not you may not create by yourself, but you're not create by your alone. You're not create by alone, but you are 100 or 1,000 people working together to create something that amazing, okay, such as Firefox, okay. There are people around the world, millions of people join to write the code for Firefox that I'm using right now, this one, okay, this web browser, okay. Okay, if you want to create your own what we call self-driving car, okay, that as Tesla doing right now, at least you have to write 100 million line of code, okay, 100 million line of code. Imagine that how long that code compared to your lecturer give you an assignment as a simple application that 100 line of code, and then you still got error from the compiler, okay. Okay. About this course, okay. This is about introduction, okay. They are talking about introduction. There are 3 credits, and then you have to pass the subject, okay. Information system analysis and design. I saw on the registration system that you got nice grade from that subject, information system analysis and design. Most of you got A or B, not less than that. I hope that subject can help a lot of you to achieve this subject, okay, because this subject is related to each other, okay. You ask me about one question, that what is different between software engineer and system analysis and design. This is the thing that we can summarize. And we can say there are two subjects that are touched in two different disciplines. Academic discipline. But they are join force to do something. Join force to do something. And we can say here, SE software engineer is focused on developing a software. They're focusing on developing a software. While information system or ISAT that you learn is focused on developing an information system. An information system cannot be built without building its software. So we can say that software engineer is a part of information system. It's a part of software information system. And then right now that definition can be moved a little bit because they are separate discipline. Software engineer may under ISAT, information system and design, information system analysis and design, or not include on system analysis and design. It may independent. It may independent. This is the course description that I took from the syllabus. You will learn about software engineering fundamental. Software process. Software process. You will learn about object-oriented principle. You will learn about software requirement. You will learn about user interaction design. Actually, this user interaction design you will learn on HDI. We call human interaction. Computer CHI. Computer human interaction by design. Actually. You will learn about computer architecture design, how to design architecture. You will learn about object design guideline. Using UML language, UML Unified Modeling Language. The world standard language for graphical design representation. You will learn about software testing, software project management, maybe. If we have enough time. You will learn about software process integration, evolution, and software supporting tool that we are going to use for create what we call the rule in terms of software engineer. This is what to learn. What to learn. This is the thing that you're going to learn. We will learn about process, method and tool of the software engineer. Software process. So requirement engineering in terms of structure and object-oriented, design essential, design methodologies, software construction, software testing, and software engineering project that we are going to do about our project. Our project is simple. It will be simple. For me, I think it's simple. I'm not sure about you. Simple, yeah, simple. The two of you is a computer. We will use a computer. I hope you have a computer. If you can join this room, mean you have a computer. A smartphone, a computer also. Visual Faraday gym, but you need a laptop more better to install some application that we can draw some diagram. To explain our idea. To explain our idea to the world. By using a standard diagram, what we call language, EML. And then try to search about Visual Faraday Gem, Star UML, Visual Studio Code. Because we have to read the code. We do not coding. Remember that this class we do not coding. You are lucky right now. You do not do coding. But you have to know how to read the code. Because software engineer is not 100% about coding. It's not about coding. If you look at the definition of the software engineer, software engineering, so you're not required to learn. You do not require to do coding, but you have to understand the coding, or programming. You need to get GitHub and GitHub desktop to upload your project, to present your project progress via a GitHub project. GitHub project. The project is simple. Run web application. Very simple. something that everyone want to what we call read every day. I hope you read up every day. So we want to make it available via web application. Okay, especially in Thai language. Okay, we have no such this web application as I know. Okay, no one did this one, and we are going to do this one for all ummah of Thailand, especially Thailand. Okay. The final project, how to do? Okay, it's very simple, right? Any idea about this?
Simple. Aja yang mudah mo aja. Apa biye?
It's simple. Okay, it's simple. You see, because we do not create from the zero, but we learn from the existing web application on the internet, and then you learn from that, and then you create your own. Okay, you create your own.
Yeah.
This one you have to do engineering of a web application. Okay. Every sentence I put here, every sentence I put on my slide, there are meaning. If you search on Google, you will find it. Okay, especially sentence that I make the bow. Okay, the bow with bow and highlight. This one, for example, you can search and you will find it. Implementing software reverse engineering. Okay, implementing software reverse engineering because you're going to do reverse engineering the existing web application on the internet. For example, Quran.com. Implementing software reverse engineering, one kind of technique that you can reverse any application that available. Okay, for web application or Android application, desktop application, whatever. This is a kind of technique. So you search, learn about this technique, and then reverse engineering of any website that you're going to do, and then to make as our project. The purpose of reverse engineering is to generating requirement, design, and implementation of an Quran web application. Okay, it is your task. Documenting in UML format. Okay, documenting in UML format. Okay, I will not accept another UML. I will not accept another format except UML. Okay, especially UML2. Okay. Okay. Where to do? Okay, you have to do on this one. Create an issue on suggestion in idea in the Noble Quran issue. Okay, you click. There we go to the link that you will open any issue. Okay, when you reverse engineering any application, you will see in terms of requirement, their design, their implementation, and then you can open issue on this idea. Okay, and on the what we call on GitHub. Okay, on GitHub issue, and then you have to work collaboratively in with your partner. Okay, or with me through the project. Okay, another tab of GitHub. Okay, GitHub.com. After you put any issue or any idea, so we can work on project to see how this project is possible or not, and then let the programmer do that feature for us. Okay, remember that we do not coding. Okay, you're lucky right now. Okay. What to do? You have to do presentation and submission. Okay, you have to do presentation and submission, or submission and do presentation. Okay, I hope can do by group. Okay, or you can do by individual. Okay, and discuss and suggestion. You want to learn more about software engineering, software development, or software something. Okay, I recommend this class for you from Udacity. Okay, udacity.com. The course is a software development process. Okay, course development process. The course is talking about how to implement UML very in deep detail. Okay, in deep detail. The gradings, normal one. Okay, the normal one. This one, the grading, I will judge based on critical thinking, creativity, collaboration, and communication. Okay, communication. The grade, if you want to get A, you have to get more than 95. Okay, if you can get 36, mean you are passed. We got D. Okay. Remember that my class is the grade. The mark is not limited to 100 mark. It can be 110, 120. Okay, inshallah, you can share the mark with your partner. Okay, with your partner. If you have
Thank you.
if you have 110, for example, I want to give this mark to my partner, so you can give it. Inshallah. This is the resource that I recommended for you to search and study. But for project that a final project is a little bit we say interesting. I will not say the problem, but it challenge for you. Okay, at least I will serve our rector what we call request that we should be close with Quran, right? Right. So if you do something about what we call project about Quran, I hope you what we call some ayah, some verses will pass to your eye and then you read it. Show to you, for example. You go to my repository. You will see this one. The noble Quran. Come on, where are you? This one, okay, the noble Quran, written by PHP. Okay, written by PHP. And then when you can go by click on this one, okay, by this link, okay, by this link, okay, where to do, okay, by this link, and then we redirect you to the issue, okay. If you look at here, there are 19 closed issue, okay, they're done by your senior, okay, done by your senior, okay. You see this one. This is we call a feature or module that have been discussed by your senior. Okay, for example, Quran feedback and help, link, tafsir, login, video, translation, semantic, crude audio, application language search, user interface and UI and UX, content, API, and so on. Okay, and so on. For example, on about user interface and experience, you click on this one, you will see that your senior is try to what we call submit. Okay, try to submit to you. Okay, let me show some things. Application language, for example. Search, for example. Okay, search, for example. Okay. Search, and then they are post. I open this issue, and then they come to discuss what should we do on about Quran, search in Quran, okay, the feature search in Quran, okay, one of feature, okay, and then they attach a file, something blah 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 like this. They are doing coding blah 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 like this, and so on. Okay, example they have been done. This one. Okay, this is by because the subject is responsible by Mito Eja. Okay, Mito Eja. Okay, this person is the GitHub name of this person who responsible this project right now as the final project for the bachelor degree of her. Okay, you will come to establish a new issue. Okay, and then you use issue to managing the project. Okay, to managing the project through the project here. Okay, through the project here. Okay, for example, here model. Okay, for example, here is feature login. For example, you come and add here. Okay, what feature according to your reverse engineering. Okay, in reverse engineering by using the standard one of modeling language, that is UML. Okay, it feels a little bit confused, but it's interesting and challenge for you to do. Okay. Any question? Muslimah? Any question?
Any question?
Okay, no question, right? Okay, no question. Mean that if you have no question, mean you understand and may you not understand, or between. Okay. If you ask question, I can know your understanding, but you do not ask and you keep quiet, I do not know anything.
อาจจะไม่กล้าถามก็ได้อาจารย์
Okay. Because any, we can say any creativity, okay, any creativity start from question, okay, start from question, and then the good answer is come from question also. Okay.
อาจารย์
You
วิ
have
ศวกรรมย้อนกลับคืออะไรอาจารย์
reverse software reverse engineering, right? It's a kind of technique, okay, technique, or which in general we call a way of learning something already exists, okay, something already exists. For example, if you want to learn how they build a smartphone, right? They build a smartphone. So you purchase a smartphone and then you assemble it, okay? Assemble it using screwdriver to open the back and then to unplug the battery and then to what we call to learn about chip inside, to remove the LED, something like that we call reverse engineering. Same as it can be implemented in any discipline, okay? Software engineering also can be in software also you can implement reverse engineering also. For example, you have one website, you want to know how they build this one, how many features. You go to that website, you see, oh, I see this, they have a login. How they designed the login, right? When you enter the login, you can see the what we call the code behind. You can see the behavior when you click, and then you can summarize that. This application consists of login, which consists of login name and login password, for example. That is we call reverse engineering. Okay, learn something from the existing already. Okay, that is all about course introduction, about the introduction to software engineering. Okay, as we know that software engineering is highly demand. Okay, highly demand that the company need a person who are good in software engineering. Okay, that we know as engineer. Okay, software engineer. Okay, so if we look at another, we call another index by higher, okay, the latest higher. You see here, there are many discipline or many jobs that require the software engineering, okay, knowledge to done that. For example, backend, full stack, front end, data science, mobile, so on, computer vision, computer intelligence, AI, and machine learning. And we can say that so all demand, all market right now, especially the market that touch about intelligent software or system or a platform, any kind of platform, buying, selling, chatting, or whatever, they require software engineer to work with, okay, to work with in terms of designing or developing, use what we call following the discipline and then make the software available for them, make software work for them, okay, within the what we call limited budget, okay. You see here the demand by engineering role in 2019 and 2020, okay, 2020, okay, 2020. The back end is the famous one, okay, the famous one that require the engineering, especially software engineering. So it pay you very heavy about this, okay. So the question is, what is a software engineer? Okay. So what is software engineering? What is software engineering? Okay. What is software engineering? Why is it important, and what are the building blocks of software engineering? Okay. If you wanna learn about software engineering, what thing that you have to learn? Okay. What thing that you have to be master? Okay. What thing that have to search? Okay. What the process method, and then the tool that you need to learn. If you want to be software engineer, okay? You want to be software engineer. This is what we will talk on this course, okay? This is the question and the thing that we will talk on the course, okay? If you look at the definition from IEEE, okay, IEEE, you say that the software engineering is application of systematic discipline and quantifiable approach to development operation and then maintain the of software. That is the application of engineering to software. Okay. In short, thing is if we the last 20 or 30 years ago, actually software engineering. They do not consider as a discipline because on that time the programmer can do coding, okay, without any engineering, okay, they just do coding. But day by day, year by year, 10 years after, 20 years after, the software become more complex. As I showed to you, they require a lot of line of code, million line of code. So they require some person that can manage that code. Okay, that can manage the software, okay, that can manage the design, that can manage the requirement of the user to fulfill the need, okay, through the development of the software. That is the meaning of software engineering, okay. Try to make the software be systematic, okay, be systematic. Systematic is by engineer, okay. Engineering mean what? Mean in scientists, okay, science. Using science of engineering, science knowledge to do the software, okay? Not by, I hope that, I think that, not like that, but by evidence, guarantee that your software will work well, okay? Based on the, what we call limitation, effort time or effort by resources, okay? This thing have to implement for the entire life cycle. Okay, from the entire life cycle, from the start to the end, by specification to the maintenance. Okay, from the getting requirement until the maintenance. There is the meaning of software engineering. Okay, in general speaking, they say that how to manage, how to build the software, make the software available to the user. Okay, to the user by using the engineering technique, okay, by using the engineering technique. That is the short meaning in general speaking, okay. Why software engineering, okay? Why software engineering, okay? Because we need something that can be measurable, okay, measurable. We do not do something that I think that, not something like that. It should be measurable by number, okay? If we say about measurable, it should be by number, okay? If we say here engineering mean predictable, okay? It should be predictable, okay? It should be quantifiable, okay? It should be theory, or methodology, or framework, or tool that support that thing to make it happen, okay? It should not say that I want to do that, but no, what we call no tool available to do that. It should not be like that. Okay, the result is a high quality of software. Okay, created in a cost-effective manner. Okay, you create the thing. The main thing of software engineering is creating high quality of software. Okay, within cost-effective. Okay, if you have the limited resource, especially cost. So how can you create software based on that resources? Okay, this is the why we need to use software engineering. Okay. If we expose about software engineering, we will see 3 layers of software engineering. Okay, there are process, method, and tools layers. Okay. Process, method, and tool layer. Okay, you see here the process layer is about a framework. Okay, framework, order of activity. Okay, for example, how to get requirement, how to design, how to do implementation, how to do testing. This is a process layer. Okay, in method, the proven technique for perform certain activity. Okay, then we have to find the technique that for each process, for example, requirement, what technique that we have to implement we have to use to accomplish a task on requirement. Okay, this is we call method layer. For example, method for requirement analysis and modeling, designing model and testing. The method for each phase or each step. Okay, tool. Okay, we need tool. Okay, what we call it can be software or hardware. Okay, especially software. Provide for what? For provide automation support. Okay, provide automation support. If we have no tool, for example, we draw by hand. Okay, we draw by hand. It's available also. Okay, it's available also. But if we have a tool, so we can guarantee that it can be automation. We can share easily. We can adapt. We can edit easily. Okay, based on the chain. Okay, based on the chain. If you look at here, we have a software creation activity. Okay, you see here there are six generic fundamental of software lifecycle. Okay, fundamental of lifecycle. We have requirements, design, development, validation, deployment, and evolution. Okay, if you learn about ISAT or information system analysis and design, you will see this is the same thing. Okay, this is the same thing. You see the same thing. This is thing that we see. Okay, that we see that how to gathering the requirement. Okay, how to design after we got the requirement. How to we take the design and implement. Okay, in terms of development. How can we make sure that our development is what we call working well by validation? Okay, after validation, how can we what we call upload or do or make some what we call deploy. They say we can deploy to the software, make the customer available to use it. Okay, and then evaluation, how what we call monitoring and then tracking our progress of the software and make it more better. Okay, in the future, or extend if the client need more feature of the software. Okay, this is what we call the main activity of the software engineering. Okay, if you learn about SDLC, it's the same thing. SDLC, but SDLC is about system, but SDLC in software because software development lifecycle. Okay. There are also activity under umbrella. Okay, umbrella activity. There is something that most people do not consider, but it's also essential. Very important to develop software. For example, here they say configuration management. Okay. Project management, quality management, process improvement. This thing is, if you create such a small application, it may not necessary. But if you maintain, you create such big application, okay, big application, huge application as e-commerce, it's necessary also. For example, configuration management. One kind of tool that we use for configuration management is version control. Okay, to control the code. So versioning our code is a part of configuration management. Okay, configuration management. For project management, how can we finish project within time and limited resources? Okay, with limited cost. Okay, this is we call project management. Okay. Any software that release, they must be respect the quality. Okay, that's why we have a quality management. The quality mean that when user use the software, it guarantee that the software will serve their need. Okay, we serve their need without any error or without any bug. Okay, and also we call process improvement. Okay, process improvement is very very important also. For example, if you want to go to Yala, right? If you want to go to Yala, so they have many ways to go there, right? Okay, so which way is better? Okay, which way is better? If you see from here, and they have, for example, if from Sarong, right, to Yala, there are two ways, right? You can go there, right? By the main way and by the mountain way. Good view over there, right? So, which way is the good? This is the responsible of process improvement. Okay, process improvement to select the which process is suitable. Okay, if you compare in the real situation, for example, login, right? Login and register. By normal website without process improvement implementation, you will see that website it requires you a lot of information: your name, your username, your password, your location, your what we call blah blah blah, your ID, something like that, right? If they implement a little bit process improvement, they just say that just use, if you use already, you sign to be the Google member, just sign in using Google. Simple, right? Something like that. This is the process of improvement. For example, you want you use an application, you don't need to make it a lot. Okay, you don't need to make it a lot. You don't need to require user to enter the information at the beginning at all. You just require their name and password, and then done. And then you can ask later for the information, for additional information. That is a part of process improvement also. Okay. Software process. We will learn about software process. Okay. As known as SDLC. Okay. In information system analysis and design, we call SDLC also, but system. Okay, system development life cycle, not software development life cycle. Okay, but they are the short term. They are called the same thing. Okay, they are joining force. They are sharing the same common things. Okay. The software process is what we call the task inside the software engineering activity. Okay, each activity they call process. Okay, they call process. Order and detail of each the task and activity. Okay, they call the process also. For example, in the process of designing, right? They are detailed, and they should have the requirement first. Then they can design. Okay. They do not design without requirement from user. Otherwise, you will design something that you need, not based on the customer. That's why they have to be what we call process. Okay, followed by process by process. Okay, flow of activity. Okay, flow of activity. It can be linear. Okay, it can be linear by parallel. Okay, single line as waterfall. It can be parallel as incremental. Or it can be rapid. It can be quick as agile or scrum, blah blah blah, whatever. Okay, the output of the software process is type or detail of artifact. Okay, type or detail of artifact. The software process can be implemented as what is the output of this each step. Okay, and then what is the input and output of each step. Okay, this is software process. For example, in designing, right? In designing, we have to use the requirement from user, okay, and then we analyze the requirement, and then we design based on the user, the process, and then we generate the what we call the design, right? User interface design, UX design, or architecture design, and blah blah blah. Okay, that is a kind of software process. The process that will guide you what step that you have to follow if you want to create a software. Okay, that is the short meaning of software process. If we look at here, there are three. Okay, actually they are from just only one single what we call way, one single model. Okay, the first one. Okay, this is the fundamental one. Okay, requirement, design, development, validation, deployment, and evaluation. Okay. Evolution. Okay. Okay, you see this one is linear. Okay, we call linear. Start from the beginning until the end. Okay, until the end. This is we call linear model. Okay, they cannot look back. They cannot do anything else. We have to follow step by step. Okay, you have to follow step by step. Okay, we call linear model. Okay, we call linear model. And another model is we call iterative model. Okay, iterative model. It can be two line or iterative. It can be parallel. Okay. You can be parallel. For example, after you got requirement, you can do design. Okay, you can do design, but can be two line of design. Okay, can be 2 person, can be 2 organization, and blah 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 until the end of the process. Okay, the new process that we are always facing, and then we will see a lot of people talking about. There is agile. Okay, agile model. Agile is, if you look at here, they are taking from linear model, okay, but they are repeating, okay, they are repeating iterative. Okay, they are repeating iterative model to be iteration 1, iteration 2, something like this. Okay, by short period of time. Okay, by short period of time. Right now many of organization implement agile principle. Okay, agile model. For what they want to release a software as fast as possible. That's why you see nowadays every software there are many updates, right? One day maybe two updates, especially on your smartphone, right? Notification that you got new update from that application, okay? Because they are using this one, agile model, okay? Iteration, okay? Agile can be one feature can be done within 3 days. One feature can be 3 hours. One feature can be done within 30 minutes. Okay. The old traditional way of software processes, it take months to complete. Okay, it take months to complete or take year to complete the circle. Okay, from requirement to evaluation. Okay, from requirement to deploy to evaluation, it take month or year. But right now they release the software or update of software within 3 days. 3 hours, 30 minutes. Okay, very fast. Okay, very fast. Especially if you see the Microsoft team. Okay, from Microsoft company, they release the feature of their software every 3 hours. Okay, 3 hours they release new. 3 hours they release new. Whatever new feature or fixing bug or fixing some kind of error every 3 hours. Okay, why? Because they are following agile model. Okay. You can see software process model. There are many. Okay, this is the name of software process model. For example, waterfall, prototype, spiral, agile, unify, aspect-oriented, component-based, formal, method, and blah blah blah. I think you already learned about this process, right? May I ask you? Any question? Any suggestion about this thing? Have you ever learned about this thing before?
Yes, we learned it before.
Yeah, you already learned it, right? So we should go by quick, right? Okay. Because this thing is sharing. They are sharing the same thing with information system analysis and design. So same thing. Okay, the same thing. Which model to use? Okay. The main thing is what model? Okay, which one that I should use? Okay. Okay, which one I should use? Okay. If you look at here, I say here decided by various factor. Okay, you have to look on various factor on criteria. Okay, including project type. Okay, what type of project? Okay, if you want to build web application, it's different with build a military weapon, right? If you want to build such a building, right? For example, you want to be building, so building have to start from the ground, right? And then build up. You cannot build the roof first and then build the floor, right? Okay, so it's different. So it depends. Okay, so that's why I say that you have to design based on various type of factor. Okay, thing that you have to consider. We call factors, including project type and maturity. Okay, maturity. If you want just build something simple and then build one and done, you can use something simple. Okay, if you want to make that project to be long project, okay, so you have to select the model that's suitable for that kind of project. Okay. I say that a software process span entire life cycle. Okay, if you select any software process, you have to stay with it. Okay, it's like you are married with someone. Okay, it's like you're married with someone. If you're married with someone, you make a decision already, so you have to spend your life entire with her or with him. Okay. So if you want to get married with any software process, so you have to consider very well based on the factor and the criteria. Okay. Software professionals often make common mistake. Okay. This one, they do not consider maintenance evaluation as part of software process, because maintenance is a part of software development. Okay, software engineering also. You do not just only build software and then let it. What we call you do not build the software and then let it run without maintenance. Okay. When you get married, right, you have a lot of things to maintain. Okay. You have to have a resource to maintain her, to serve her, whatever, blah blah blah. That's what we call maintenance. Same thing as life. Okay, in software development. That's it. They consider requirement to deployment but neglect operation. They just consider something like this. Okay, requirement development but neglect operation. They have to, when you select any life cycle, you have to consider operation. Okay, operation. What requirement of that model can do? What thing that we should do on that requirement? Okay, for example, if you choose to use waterfall, right? If you choose to use waterfall, you have to complete all things at each step, right? And then you can move to another step, right? So it's different when you're choosing agile. Okay, you don't need to complete comprehensive anything at the beginning, and then you can move to a next step, right? Because you can do iterative. Okay, iterative 1, iterative 2, iterative 3, blah blah blah, whatever. This is different. Okay, it's different. If you compare with life of human, you are using waterfall is we get married. Okay, we get married. If you are using agile, like you have got a boyfriend or girlfriend. Okay, something like that. It's easy to understand, right? Okay. Software engineering method. Okay, in software engineering method, we see here. Okay, we have tool. Okay, we have three layers of software engineering method. Okay, we have tool, we have method, and we have process. Okay, we have tool. We can call process method 2. Okay, process method 2. You see here, the process is used to order, forecast, and artifact. Okay, order, focus, and artifact. The method is how to. Okay, the main thing of the main job of the method is how to modeling and notation. Okay, modeling and notation, the main thing. Okay, this one. You see here the practice of method. Okay, the practice with proven technique. Okay, the proven technique to perform certain activity in organized and systematic approach. Okay, in organized and systematic approach. Okay, it should be something that systematic. Okay, systematic means measurable. Okay, measurable, something that countable. Okay. Similar, there are method for design and testing. Okay, there are method design and testing. The most known software method is this one. Okay, structure, object, formal method. I think that you are already familiar with this one. Object oriented analyze and design. Okay, object oriented analyze and design. This is we call method. Okay, we call method. The way we achieve the task of each process. Okay, for example, we select to work with agile. Okay, for example, we select to work with agile, and then we want to complete the agile, and our software should be implement some kind of method, and then we choose to work with object oriented analysis and design. When we choose to work with object oriented with object oriented, so we have to do design, requirement design, implementation, deploy, testing in the object-oriented principle. Okay, in the object-oriented principle. If you choose object-oriented analysis and design, if you choose another, you have to follow that thing. Okay. There are two. Okay, we talk about process. Okay, process that guide us to do what. Okay, and the method guide us to do how. Okay, to do how. Okay, the software tool is it help us to do but what we call by automating. Okay, make us more easier to documenting, to do coding and blah blah blah. Okay, by, as I say here, the tool assists software process by automatic action. Okay, by automatic action. So you use the software process. We use the software tool. Okay, software engineering tool for make the software process. Okay, start from requirement to deploy. Okay, by automating. Okay, automating. Try to do not do by yourself by any process. Okay, any process. They should be automating. For example, testing should be automating. Okay, not test by human every feature, because if we have 100 of feature, so we have to test every feature. So it make human tired to test and then make error prompt. Okay, make error appear to you. Okay, that's why they had to do by automating. For example, here you look at here, you will see the requirement management, right? Requirement management. You can use this such kind of tool. This is the name of tool. Okay, I like to use a visual paradigm. Okay, that's what I propose here. Okay, this is my personal application that I use. Okay, visual paradigm. If you are familiar with rational rows, IBM is okay. Okay, you can use anything else. Visio, Microsoft Visio also, but there's not best practice. Okay, because there is what we call Microsoft Visio is multi-purpose. Okay, multi-purpose for any kind application, any kind of development, not focus on software development or software engineering. So you can search about software paradigm, a visual paradigm. You can see it. Okay, you can see that visual paradigm is the nice tool and easy to use. You can do reverse engineering by using that tool. Okay, and your project you can do that. Development. Okay, development you can use IntelliJ idea. Okay, IntelliJ actually they call IntelliJ idea. Okay, this is the famous and become the most top IDE for developer right now. Okay, for developer right now. Testing you can use Selenium. Okay, Selenium. Okay, software configuration you can use Ansible or GitLab or GitHub. Okay, there is a software configuration. Okay, for project management you can use visual paradigm or enterprise project management from Microsoft. Okay, from Microsoft. You can create a Gantt chart over there. You can manage time, people, budget, how much cost it takes to complete the software, how many person involved in that project. Okay, how many months or a week to complete that software. Okay, based on Gantt chart, for example. Okay, process management and modeling. Okay, you can use a visual paradigm also by using BPMN and BPMN, business process modeling notation. Okay, process modeling notation. You can use this one to modeling the tool based on the business process. Okay. The role of software engineering. Okay, you want to be software engineer. Okay, you want to be software engineer. This is the role of you. Okay, the role of you, or thing that you should do as your job. Okay, usually, or thing that you will do every day of your life. You consider yourself as software engineer. For example, I say I'm software engineer. What thing that I should do with this? What in this we call job or in this demand? Okay, you say that software engineer as a role less formal defined than the discipline. Okay, software engineer is replace the title of software development. Okay, say indicate more knowledge responsible, so more sophisticated. Okay, if you consider yourself as software developer, you just develop the software, but you don't know how to engineer the software. If you consider as you are software developer, you know how to do coding. Okay, you know how to do design, you know how to get the requirement from user, but not in systematic way. Okay, you should do that thing by using the systematic way. That's why software engineer is more better. Okay, in the short meaning is to say that anyone who efficiently apply the engineering discipline to the analysis, design, development, testing, and operation is qualified as software engineer. Okay, anyone that apply engineering discipline. Okay, engineering discipline. So you use engineering discipline. Okay, by systematic. Okay, to analyze, design, and develop, testing, and operation that software with qualify. Okay, with qualify, we call software engineer. Okay, software engineer. You wanna be software engineer, so take care of this one. Okay, take care of this one. Okay, software engineering and project management. Okay, project management is some kind of to make the project done within the time and cost. Okay, project management is the thing that the driven software engineering to make the project done within the time and cost. Okay, kind of cost. Okay, so just that is the meaning of software project management. Okay, software project management. Okay, it applies from requirement to retire of software. Okay, it apply from the requirement to the retire. Okay, retire the software. Okay, maybe some kind of software engineer, they don't know how to plan. Okay, they don't know how to plan the project. Okay, they don't know how to plan the project. That's why they have to learn about project management. Okay, there may be another person who is the project management engineer. Okay, who plan the project, and then the software engineer will follow the guideline from that person. Okay, you see this one. The main task of project management is to control. Okay, control the project, communication in the project, cost analysis. Okay, work breakdown structure. Okay, task scheduling and risk analysis. Okay, cost analysis, for example, how much it will take cost for this project. Okay, work breakdown structure. Okay, how many person that it required to work in this project. Okay, for example, if someone cannot continue to work on that project, how can I find another person join the project? This is the task of project management. Task scheduling. Okay, for example, if you want to design. Okay, you want to design. How many tasks for designing? Okay, the step of designing. What is step of designing? For example, you have to take requirement. What requirement you will take? What design you should design based on what? UI, UX, what, blah blah blah. For example, okay, you have to make a task scheduling. Okay, when the design will done. Okay, it should be time limitation. Every step should be time limitation. Okay, you should not just let any step go and no stop. They should not be like that. Okay, otherwise the project cannot be accomplished. Okay, within the given time and cost manner. Risk analysis. Okay, risk analysis is they use to analyze the risk of the project. Okay, for example, there are many requirements. How can you done within a limited time? Okay, and then with the limited resource. For example, you receive some kind of project, okay, and then you want to analyze the risk that I will get profit, I will lose on this project. This is the task of list of analysis. Okay, risk of analysis. Okay, so we book. Okay, so we book as known as software engineering body of knowledge. Okay, if you want to refer to any software engineering definition, okay, definition and principle, please refer to this book, okay, because it's released by IEEE, okay. IEEE Computer Society is organization that we can say that they release many standard, okay, wireless communication, computer device that make that hardware and software working together. That is the responsible of IEEE, one of the organization. They make the standard for many hardware and software of computer. Okay, one of book they release is we call software engineering body of knowledge. Okay, in short name we call SWE book. Okay, SWE book. Okay, as an international standard. Okay, international standard. If you want to follow anything, please be standard one. Okay, if you say that what is design, you should refer to this one. Okay, what is design in terms of we call software engineering. So they can be referred and then give the definition of the design, for example. Okay. Okay. SWE-BOK, they represent 15 knowledge area in software engineering. Okay, 15 knowledge area in software engineering. If you look at here, they are huge. demand huge knowledge about software engineering. Okay, start from software requirement, software design, software construct, and blah blah blah, and so on. There are many. Okay, there are many. So the red ball is our discussion on this course that we will talk on this class. Okay, and we will talk on the subject. Okay, we will talk about software requirement. Okay, we will talk about software design, software construction, software testing, software process, and modeling and method. This is just 6 from 15 knowledge area that we will talk on this subject. Okay, based on the title of our subject is Introduction to Software Engineering. Okay, which book of this book I already upload to the Google Classroom. Okay, you can open this one. Okay, you can open on the resources and upload it already, so you can try to read this one. For example, this one software requirement. If you want to learn about requirement, something like this, they show to you already what is software requirement, how to do, what method, what process that can be done in software requirement. Okay, this is the content that we will discuss. Okay, we will discuss. Okay, we will talk about process, method, and tool. Okay, we will talk about process model. Okay, process model. We will talk about requirement engineering process. Okay, because every process, every activity in the process, there are what we call ecosystem of itself. Okay, for example, requirement, they have their own process. Okay, how to get the requirement from the user, from the customer, they have their own process. Okay, we will talk about requirement modeling of the structure analysis and then object-oriented analysis. Okay, I consider as a method. Okay, consider as method. Okay, essential of software design process. Okay, what process for if you want to design software? What kind of process? Okay, how many process it will take to design some kind of software? Okay. And then what method that we use to design software? Okay, high level, low level, something like that. Class diagram, architectural design, something like that. That we will talk. Construction process. Okay, how we do coding. Okay, how we do coding. In terms of software engineering, we do not do coding and go coding like that, but we do structure. Okay, the structure the coding. Okay, structure the coding. What you should start, what programming language you should select for this project. Okay, what thing that you should consider. Okay, what IDE, for example, what kind of computer, how many RAM, how many gigabyte of what we call RAM or hard disk that will be used in terms of construction. It will be on this process. Okay, process. Testing process and method. Okay, testing process and method. We will talk about testing. When we build a software, okay, we build a software, we not just let the software work like that. We have to test, make sure before we release the software to the customer, okay, to the user, that make sure that our software is working well, okay, without any error or bug. We have to do testing. Okay, we have to do testing. Okay. The testing is kind of a step that a little bit boring, but it's essential. Okay, it's a bit boring, but it's essential. Okay. In summary, we can say that software engineering is an application of systematic discipline and quantifiable approach to development, operation, and maintenance of software. Okay. How you develop software based on discipline, okay, by using systematic, not just say and then doing like that, but systematic. Okay, you have to follow step. We have a guideline, we have a process, we have a method, we have a tool. So this is we call the systematic or discipline on the software engineering. Okay, so software engineering is applied to the entire software life cycle. Okay. The knowledge of software engineering can be implemented on any field. Okay, for example, you want to be back-end. Okay, you want to be back-end development or front-end development. It requires software engineering knowledge to implement it. Okay, to make that thing systematic. Okay, systematic and disciplined enough. and then follow the standard guideline, and then we can work together for many person by group. Okay, there are 3 layers of software engineer. Okay, process, method, and tool. Okay, process, method, and tool. As we say, the process is activity, task. Okay, process 1, process 2, process 3. Okay, if you want to do some kind of software, what do you think that you have to consider in process, especially their requirement, design, development, testing, deployment, and evaluation, right? This is the main, the common and generic process in software engineering. Okay, the method layer is practice with a proven technique to perform certain activity. Okay. After we got each process, right? For example, requirement. Okay, for example, requirement. We have to find the method that how can we done the requirement. Okay, how can we done the requirement? That's we call method. Okay, and then a tool layer. So what tool that can assist us, okay, to complete that process. Okay, that method. Okay, by make it automating. Okay, they try to move from the manual to automating. Okay, that is all about introduction to a software engineer. Okay, if you search about paradigm, visual paradigm, you will see a tool that we can use for software engineering for entire circle. Okay, so your life circle. Okay, this one. It can use for agile process. It can use for user story. You can use for PM, project management, Gantt chart like this. You can use for enterprise. It can be used for what we call this one modeling. Okay, modeling. It can be used for visual modeling, UX design, use case management, for example, use case management, database engineering, coding engineering. An assignment for you is go and learn how to use visual paradigm. Okay, install and use it, visual paradigm, because it's available for you to do most of everything. Okay, about software engineering. Okay, software engineering, especially requirement analysis and design. Requirement analysis and design. You see this one, you have the price architecture. Okay, you design architecture of the application. Okay, your business design, for example, here you can do reverse. If you want to design some kind of application, so you can start design by using the application by drawing icon. You see, start from where to the next, something like this. Okay, connect to database, the message from something, some channel, come to your system, come to requirement. CX UX. Okay, CX UX available also to design on this application. Okay. Quality control, for example, quality control system design. Okay. You learn about database, right? This is one of you can design ERD. Okay, entity relationship diagram. Okay, you can draw UML. Okay, use case, class, package, deployment, sequence, or whatever by using visual paradigm. Okay, and then related to our projects. Okay, related to our project, you have one thing that we call sorry, where is it? Reverse engineering. Okay, reverse engineering. This application can be used for reverse some kind of application. Okay, some kind of application. You can take application and then you can reverse see the detail inside the application. Okay, in terms of requirement, analyze and design of the application.